Hi, my name is John Dean. I'm a faculty member here at the University of Alaska Fairbanks Geophysical Institute. I also work for the Alaska Volcano Observatory, where we monitor volcanoes all the way from Northern California through Alaska and into the Coral Islands. That's about 20% of the world's total active volcanoes. So we see a lot of the products that volcanoes produce. We get about an eruption every month or so in this region that produces not only volcanic ash, but a lot of volcanic gases into the atmosphere. This picture here is actually not from Alaska. This is Grímsvötn volcano in Iceland, and it can show the huge eruption cloud and give you an idea of the impact that volcanoes can have on the atmosphere. So, one of the huge questions that we deal with is, why do volcanoes erupt? This is one of my field assistants at Volcanoes volcano in Italy. This is sort of the type locality for volcanoes, and you can see it's constantly degassing. Now clearly it's not erupting at this time, or we wouldn't be standing right next to it. But there's all of this sulfur and there's all of this steam, and that steam is made not just of CO2, but also water vapor and other gases. So water, that's why volcanoes erupt. Under high pressure and at depth in a magma, water can be dissolved into a magma just like CO2 can be dissolved into a magma in the exact same way that CO2 is dissolved in a soft drink. And when the magma cools or when the pressure goes down, those bubbles come out. So if you take a can of soda and you shake it up, all the bubbles come out and the thing can even explode. Similarly with volcanoes, they can be triggered by earthquakes, or as the magma cools, the bubbles come out, the density goes down, and the magma wants to make its way to the surface. And if it happens quickly, if you add water suddenly to a system, it can flash to steam, which is over 1,000 times increase in volume in an instant, and that can cause huge explosions. But water, as I said, is not the only volatile, that's the term that we use, that can trigger an eruption. It's just the most common. It makes up about 80% of, and each volcano is a little different, but about 80% of the volume of all the volatiles that trigger eruptions is water. But about 15% is carbon dioxide, and about 5% is sulfur dioxide. Now, the way we get at how much gases a volcano is putting into the atmosphere is we measure SO2. And the reason we measure SO2 is because SO2 we know primarily comes from the volcano, and it's easy to measure spectrally. The problem with CO2 and water is it can have other meteoric sources. So eruptions put out a lot of gases. This is the March 26, 2009 eruption of Redoubt volcano in Alaska, and you can see these things are global events. You have the limb of the planet here and the eruption cloud, which actually got up into the tropopause. A huge, huge event. This was actually a smaller eruption 3 days earlier, and with various satellite sensors we can actually measure the amount of SO2 in the atmosphere. And here, this is Alaska. This here is the Gulf of Alaska. Here's Cook Inlet. Anchorage is here underneath the volcano. The volcano is this little triangle here. And this is measuring the amount of SO2 in the atmospheric column. This is one eruption on March 23rd, and it produced about 42 kilotons of sulfur dioxide. Now, if you go back to our ratio that we had before, about 5%, give or take, of the volcanic gases are sulfur dioxide. About 15% of the volcanic gases are CO2. So a good rule of thumb, it doesn't apply for every volcano. Everyone is different. But it's a pretty good average that if you multiply the sulfur by 3, you get the amount of CO2. So for this eruption, we're probably looking at something close to 150 kilotons of CO2 from one, in this case, one volcano, one event of 19 separate eruptions, and not even the largest ones. That gives you an idea of the magnitude of gases produced by the volcano. This is the sulfur dioxide cloud that we saw from Kasatochi volcano, which is located here out in the Aleutian Islands. On August 12th, 2008 is when this image was put together. And you can see that the gases, even from a remote volcano like Kasatochi, end up going around the entire planet and impact the whole atmosphere. And here high concentrations of gases out into the Pacific, here over the Great Lakes, here over the Pacific Northwest, and of course the Arctic has a great impact from these gases. This eruption was much, much larger than the Redoubt eruption and put many hundreds of tons, kilotons, of CO2 into the atmosphere. But the thing is, we like to focus on volcanic eruptions. And volcanic eruptions are great and spectacular and gather everyone's attention, but volcanoes degas all the time, every single day. Here's a couple of examples. This is Mount Cleveland in Alaska, and there's a small plume coming off the top of it. It's putting out a little bit of gas every single day. There's always magma down there, always doing it. Here at Kilauea, Hawaii, that volcano is a little more active, tends to put out more gas. You can even see some incandescence there, and constantly, 24 hours, 7 days a week, 365 days a year, putting out gas. Next. So one of the ways we can measure gas is not only from space, but we want to calibrate that on the ground. It's one thing to look at something from space, it's another to know what's actually happening on the ground. So we go out to volcanoes. Here we are at Kilauea Volcano with an infrared sensor and an ultraviolet sensor, recording that with a computer, looking at the gases coming out of the volcano. This is sort of this thing is that thing over there. We're sort of looking at a different view, and there's several vents here that are constantly putting out the gas in this dreadful fog. The reason I put that up is we'll see an animation next of that same exact view, and you can see that it's, first off, the gas coming out of the volcano is not always constant. It varies. It varies on a matter of seconds. So sort of measuring the amount of gas coming out per day, well, that's a pretty rough average. And some days are obviously bigger than others. Some moments are even bigger than others. But constantly producing gas in each little vent at a different rate and at a variety of places on the volcano. Now, there are about 2,500 volcanoes, potentially active volcanoes, worldwide. About 650 of these are, give or take, are historically active. And boy, I hate that term, because historically active doesn't really mean anything. Because volcanoes have lifespans that are in millions of years, and human history is what? You know, a few hundred, and if you go back to some very remote places, it's barely even 50 sometimes. And they're scattered all around the world at the junctions of different tectonic plates, usually at subduction zones. So here in Alaska we have this large subduction zone, which is the source of most of our volcanoes, here in Kamchatka as well, down through Japan, the entire ring of fire. But there are volcanoes in the old world in Europe, there's Iceland, there's of course all the Italian volcanoes, and many in the Indian Ocean and in Africa at this rift zone coming down here near Mount Kilimanjaro, which itself is a large volcano. So let's think about some facts about volcano degassing. As I said, they degas all the time, non-stop. We've had volcanoes on planet Earth for literally billions of years, and they've been doing it the whole time. There are about 2,500 potentially active volcanoes at any given time, and it seems reasonable to believe that number was about the same. There's some indication that in the Cretaceous, more than 65 million years ago, that we might have had a large increase in volcanic activity that produced even more greenhouse gases and CO2. But overall, if you're going to average up the 4.7 billion year history of planet Earth, about 2,500 seems a reasonable number. About 1,600 have erupted. I said 650 on the other slide. Those are the recent historic. Here, depending upon how you define historic, you could get 1,600 eruptions in historic time. And a volcano's lifespan is measured in millions of years, so they're not going to stop anytime soon, and there isn't really any way to stop them. So let's do a little math, given all of this. As I said, not every volcano erupts at the same rate, but or puts out gas at the same rate. But, you know, there's the ones that put out a lot at about a ton per day, or most of them not too much, and then a few, 50-ish or so, that put out about a kiloton per day. And we spread this out in what seems to be a plausible ratio. And we've been measuring a lot of these volcanoes for decades now, and we get a pretty good, you know, any range from fewer of them at the large rate, producing 50 kilotons, to about a kiloton for about 1,000 of them Multiply that number by 3 to get the carbon dioxide input, so about 150 kilotons per day from the big volcanoes and about 3 kilotons a day from the majority of the not so active volcanoes. And then the amount of water that comes out, that's important as well, because water is as well a greenhouse gas that can have serious effects on the climate. And this comes out, if you average this up for a year, to be about 44 megatons of SO2, about 120 megatons of CO2, and about 748 megatons of water every year. Now you add the eruptions. At any given time on planet Earth, any given day, right now as we're talking, there are about 10 volcanoes erupting. That seems like, oh, that's a lot. You know, it's like the end of the Earth or something. No, there's 2,500 volcanoes on planet Earth. It's actually a very small percentage. And some of the volcanoes that erupt all the time, like Kilauea, Mount Etna, Mount Erebus in the Antarctic, you know, they're tourist attractions. People go and see them, and it's okay. It's just part of the planet's natural life cycle. But each of those adds much over a kiloton per day of SO2 and over then 3 kilotons per day for each single volcano of CO2. So that gives us, if we add all of that up, the passive degassing as well as the eruptive activity, in an average, and this is just a rough ballpark number, but not too awful bad, about half a gigaton of SO2 per year, 1.5 gigatons of CO2 per year, and almost 5.5 gigatons of water vapor per year put by volcanoes into the atmosphere. Now, some of you may realize, well, this number seems a little larger than has been reported in the past, and that's true. Always go back and check the data yourself if you can. It's a really good idea, and one of the big tenets in the science that we do is don't believe what someone else told you. Go find out for yourself. Go do the numbers for yourself. And we see that volcanoes have been doing this for a long time. 1.5 gigatons per year CO2 for billions of years. Whoa, that's a pretty big carbon footprint just from the volcanoes. So, and this of course goes into the planetary carbon cycle, and this is how nature works. So, thanks a lot for your time, and if you'd like to know more about Alaskan volcanoes, visit us at the Alaska Volcano Observatory at www.avo.alaska.edu.